All right, here's one more acceleration type problem. So let's say I have somebody standing here and they toss a baseball into the air. And they toss it up with a velocity of 30 meters per second. So as I said, I like to make my initial velocities positive. So I'm going to say VI is 30 meters per second. The question is, how do I then define acceleration? If the ball is being thrown up, gravity is pulling downward. So even though acceleration is 10 meters per second squared, because it's in the opposite direction the ball is going, we're going to have to define it as negative because it's not going to make the ball go faster. It's actually going to slow it down. So I'm going to write A as negative 10 meters per second squared rather than positive 10. And in this case, it wants to know where it'll be 4 seconds later. There's nothing special about that 4 seconds. It's just we picked 4 seconds out of the air. That's what it wanted to know about. So what will its velocity be in 4 seconds? So how do I approach that? I can use this equation if I like. So VF equals VI. VI is 30 plus A. In this case, A is negative 10 times T is 4. So I get 30 minus 40. That'll be negative 10. So after 4 seconds, the velocity will drop to negative 10. And the reason is because the ball is going to be going up, and then it's going to gradually slow down. It'll be going 20 after 1 second. It'll be going 10 after another. Then it's going to stop and be going 0. And then it's going to turn around and start falling. And so it's going to be moving downward at 10 after 4 seconds. So that's the logistics of how this works. So now what I want to do is figure out this ball right here, where is it in relation to the thrower? So basically I'm asking for delta x. So again, if I want to skip ahead and use this equation, I can. Delta x equals VI, 30, times T, which is 4, plus 1/2 A, negative 10, times T squared, 4 squared. So 30 times 4 is 120. 16 is 4 squared. 16 times negative 10. So I get negative 160, I get negative 80 here. So what is 120 minus 80? I get 40. So basically the change in x is 40 meters. So that tells us if the ball was thrown here, the new location of the ball is currently 40 meters above where the thrower is. So if I were going to answer the question, I would say, I might even go farther and say the ball is falling because that's what it's doing at 10 meters per second. And it is 40 meters above the thrower. And that's how I would do it one way. And again, if I want to do it the other way, I can say, what is the average velocity of 30 and negative 10? So this is a little tricky. Add them up and divide by 2. So 30 and negative 10 is 20. The average is going to be 10. 10 is in the middle of those two. So if you go an average of 10 meters per second for 4 seconds, you're also going to get 40 meters. So again, if you like to do it both ways and just confirm the answers check out, that's a good way to confirm your answers are correct, but you don't have to. So anyway, that is a more complex problem where the acceleration is the opposite. I could have chosen any other time. If I wanted to know how far the ball is at its apex, I would choose the time when it reaches a velocity of 0 because at its maximum height, its velocity is 0. So in that case, I would choose a time of 3 seconds. That's not really what this problem is asking for, but just throwing that out there. Anyway, until next time, I am Derek Genova. Have a delightful day.